All right. So, ferry approaches shore moving north at the speed of 6.2 meters per second relative to the dock. So there's that one. We call that the speed or the velocity of the ferry relative to the dock or the shore. Let's say dock, I guess. Something stationary. A person on the ferry walks from one side of the ferry to the other, moving east at a speed of 1.1 meters per second relative to the ferry. So the speed of the person relative to the ferry. And that has a magnitude of 1.1. And we want to know, what is the speed of the person relative to the dock? So we have two different things, all right? So using our general format, v12 plus v23 is equal to v13 in terms of vector addition here. Okay? So, again, we could have drawn these in the opposite way, but it doesn't really matter. So here, VPF plus VFD is equal to the velocity of the person relative to the dock. 1, 3, person, dock, which would be represented by this guy here, VPD. So, this vector is due north. This vector is due east. So this problem is not too bad. Can we just go right into the Pythagorean theorem on this problem? Since these two vectors do make a right triangle, one's due north, one's due east, we can avoid having to do the entire table. I mean, you could still make a table if you want to, and I can show you what it looks like, but it's essentially just going into the Pythagorean theorem to figure out the magnitude of this. All right. So the person relative to the ferry was 1.1 meters per second, and the ferry relative to the dock was 6.2. So again, we are combining these two vectors. Even if you drew it the other way, we are combining these two vectors to find a result in this vector. So again, even if we drew it like this and like this, it's the same thing. Just for a second there. So VPD is equal to 6.2 squared plus 1.1 squared. Plug that into our calculators and get our answer. So about 6.3 meters per second there would be the magnitude of that. They only ask for the speed, so that's all we have to give them to them. But generally on a test or quiz, I ask for both the speed and the direction, or the velocity. So if I do just say the velocity, that would mean both the speed and direction. And as always, you can find the direction by doing the inverse tangent of the y component, 6.2, divided by the x component, 1.1. About 80 degrees north of east. Now again, even on simple problems like these, which I imagine should be easier for everybody, but even on problems like these, you could make a chart. It's just that there's going to be some zeros in the chart. So let me show you that really quick. The chart is your fail-safe. The chart always works. So again, you have VPF, VFD. Those two combined are going to equal VPD, following that pattern established up there. X components, Y components. So, VPF, that's this guy. What is its X component? its x component is 1.1. Its y component is 0. VFD, its y component, or its x component is what? 0, and its y component is 6.2. So we add the columns, and you wind up with the two legs of our resultant, 1.1 and 6.2. And then, as always, again, this is where we get our sum. These are the two legs of your resultant. So, obviously, you were just given those off the bat. But, just putting it in the context of a chart, maybe that helps make a little bit more sense out of it. I don't know. But, that's how that would go down. Any questions there?